Problem number 2 is challenge. Drop the microscope. You have 1 minute to make decision. Problem accepted. So in total, you got 5 minutes to prepare for your presentation, and also write down the representative's name on the drop-down, please. Right, it's your time for 12 minutes.
Honorable judges and fellow competitors, I'm the reporter from TYPT S602. So today I'm going to talk about problem number 2, droplet microscope. And this is the outline of my report. So for part statement, we said by looking through a simple water droplet placed on a glass surface, and one can observe that the droplet acts as an imaging system. And you have to investigate the magnification and the resolution of such events. And there are 3 main focus in my report. So one is how to get magnification and resolution. And another will be how to slice of different weapons affect this phenomenon. And another will be how to decrease the error. Okay. And for my observation, then you can see that the section which was covered by the droplets will be magnified. And when I use different methods of light, then the resolution will also be different. And this is my experiment setup for magnification. First, I use pipette to control the volume of water, and also use tripod to control the position of foam. And I put the water on the slide, and I put the graph paper onto the slide. And this is my procedure for the magnification experiment. Then I place the droplet on the slide, and I also change the object distance by adjusting the springs of the equipment. And I use the graph paper as a scale and object to observe. And this is my experiment setup for resolution. And I also use pipette to control the volume of water, and I also use tripod to control the position of the foam. And for source of light, then I can use a plate or a foam to give a pure color picture. Okay, and for procedure of the resolution experiment, then I try to change the RGB value of light and also change the object distance. Okay, and for shape of the water droplets, because of surface tension, it will shape like a lens just like this. Okay, and for magnification, we can observe that the magnification edge will be larger than the middle part. And for resolution, it's actually be affected by the diffraction of light. And on the left is the true size pixels, and on the left is the pixel which has been deflected by the droplets. Okay, and this is my schematic of my experiment. First, I set the object distance as P and the image distance as Q. And this is how the image forms. It's actually the virtual image on the same side as the object. So first, I use console to simulate the weight of light, and it's the most significant factor that affects this phenomenon. And for the shape of the water droplets, it's actually be affected by the surface tension, and which will make the water to form like a sphere. And we also use console to simulate the shape of the water. And you can find that when I use the variation of pressure to simulate the shape of it. Okay, and for the width magnification, then I use lens maker equation to get the focal length. And in my experiment, I can simplify this equation like this and combine it with the Gauss formula, which can let me get the final magnification that I want. And second, we also have to consider the depth magnification. And this equation actually describes the magnification of the real image. So I have to modify it. Then I can find that the depth magnification is very close to 1, which means that it doesn't affect the phenomenon very much. Okay, and for the types of the resolution, there are mainly 2 types of resolution, and one would be the image resolution, which actually depends on the density of the pixel, and the other will be the optical resolution. It's actually based on the wiring criterion, which is affected by the deflection of light. And the definition of resolution here is the optical resolution. And for the definition given by the wiring criterion, it supposed 2 objects, and the light emitting from 2 objects will go through a circular hole, then the diffraction will occur. And because of the interaction of the constructive interference and destructive interference, and it will form like a shape of intensity just like this. And when the ones of the highest intensity over them will be others lowest, then you can observe the one's image obviously. So based on So based on this, then we can define the minimum distance at which the points can be distinguished by individuals. But here might be some confusion of the optical resolution. For my example, there are two pictures. Then which one's resolution will be better? The answer is it's not sure, because the definition of resolution is actually based on the boundary that the image can be seen and cannot be seen. So we can not just use one picture to define the resolution here. Okay, and for a formula given by various criteria, we can calculate the minimum distance that the point can be distinguished by individuals at this formula. And the resolving power will be inversely proportional to the thing here. Okay, and I changed the equation with my experiment parameters and replace it, then I can get the final equation that I want. Okay, and for optical resolution, actually it will be affected by the wavelengths, just like the equation I have mentioned. So we couldn't use white light because the wavelength of white light is uncertain. So I have to use the pool color, for example, like red, green, and blue lights. And for my prediction, I predict that the resolution of the blue light will be better than the others from the equation. Okay, so for my analysis of my experiments, I have to consider the spherical aberration, which is actually caused by the different focus of light, and will make different magnification and the resolution. And also use console to simulate the spherical aberration. Then you can find that when the bottom area is larger, then the spherical aberration will be more obvious too. And how should I avoid the spherical aberration? That I tend to only observe the center of the droplets. So I have to also consider the chromatic aberration, and which is actually caused by the different reflected index of light, different color of light. I use Cauchy's equation to calculate the different reflected index of light. And I found that the error is smaller than 1%, and so I think it's actually ignorable. And next, I also have to consider an angular magnification, because the magnification recorded by the camera is actually based on the angular magnification. But after I calculated this, I found that it won't affect the magnification too much. It can be written just the same as like the definition of magnification I have mentioned. And I have to also modify my experiments, because the value of the object distance will be will be influenced by the slide. So I have to modify it. And for my experiment method, I mark a cross on the slide to ensure direction, and use a pipette to drop the droplet on the slide, and put a graph pattern on the slide as a scale and object to observe. And I use ImageJ and kappa to analyze the curvature radius, and use Python to plot the graph. Okay, and I set the scale of the graph pattern. Okay, and you can find that if I set the 0 points as the left side of the droplets, and you can find the curvature radius change with the x coordinate. And when I smear some wax surrounding the droplets, then the curvature radius will be changed. So my experiment y-1 will be the relation between the object distance and the magnification. Then I found that when the object distance is larger, then the magnification will also be larger. And the last point in my experiment is actually caused by the spherical aberration, which affects the phenomenon. And for the relation between the magnification and curvature radius, I found that when the curvature radius becomes larger, then the magnification will become lower. Okay, and for my experiment for resolution, then I replace the parameters with the parameters in my experiments. Then I can get the final equation. And you can find that I use different wavelength lights, and they are respectively red, green, and blue, and which is actually provided by the RGB value. Then I can measure the object distance here, which has been modified. Okay, and for my results of experiment 2, then I found that when the wavelength is larger, then the resolution will be lower because you should get more closer to the object to distinguish them, and which means the resolution of this is lower. Okay, and for my conclusion for the phenomenon, and for the problem statement is that you have to investigate the magnification and resolution of such a lens. Then, so I use console to simulate the trail of light, and which can help us analyze and check the method to analyze this phenomenon. And the shape of the droplets will be determined by the surface tension. And I also use console to check if different radius will change the shape of the droplets. Okay. And for the magnification part, I found that when object distance is larger, then the magnification is larger. And this phenomenon will be influenced by this spherical aberration. And it's very hard to completely avoid in my experiments. And I found that when the curvature radius becomes larger, then the magnification will also become lower. Okay, and for the conclusion for my resolution, I found that when the wavelength is larger, the resolution will be lower because you have to get closer to the object that you can distinguish them. And actually, this definition is given by the grading criterion, which is based on the deflection of light. And all my presentation, thanks for your attention.
All right, thank you. Questions from opponent to reporter for 2 minutes?
So I have some questions I want to ask you. So the first question is, can you make sure the shape of the droplet is the same? Yes or
You
no?
mean,
The droplet, the shape of the droplets.
what's the definition of the shape of droplets?
I mean, when you use the pipette and to drop the droplet, is
I
this?
control the volume of it because the shape will be
Okay,
affected
thank
by
you.
the
Then what's
surface
the
tension.
next question is, did you make sure the glass you use is horizontal or not?
Yes.
Okay, then what about, do you think the magnification, the one which will affect the magnification most is the focal length or is the curvature radius?
I think the object distance will affect the most.
Object distance will affect more than the other one, the other two, right?
Yeah.
Okay, so what is the, you think which one will affect the resolution more? The diameter or the wavelength you mentioned in your presentation?
Actually, I think it will both affect it very much.
Okay, so what about, do you think the magnification will have a limit?
The limits.
Yes, a limit.
Could you describe your question more specifically?
Like when you have your imaging will be magnified, right?
Yeah.
And you have a limit, it's like it will magnify in a probably will magnify like two. Okay, so in your experiments, you found an aberration, right?
Yes.
And what kind of aberration you have? Because in aberration there are a lot of conditions of it, but you didn't mention in your presentation.
I got the average of the curvature radius.
Okay, thank you. And you say that the curvature radius increased and the magnification will decrease, right?
Yes.
Okay, then is there any, like, why the curvature radius decrease and the magnification will increase? Why this will be opposite?
Because the curvature radius will change the focal length of the droplets.
Okay, thank you.
All right, opponent, you've got 3 minutes to prepare for your comments and discussion with reporter. It was a connector, isn't it?
应该是那个投影机。
Yeah, do France. Okay, all right, yeah. All right, opponent, you may take the floor for up to 4 minutes and proceed to discussion with reporter for totally 14 minutes.
So, hello everyone, my name is from Eastleigh, and now I'm going to oppose the problem number 2, droplet microscope. So, in my presentation, I will mainly focus on whether droplet can be seen as an imaging system, and how do the relevance parameter affect the results. So, to overview the reporter, in his theoretical model, he got the Young's equation and Rayleigh criterion, and different direction of resolution and Gaussian optic, and Lensmaker's equation and simulation of the shape of water. In here, his proofs have the explanation and definition of the resolution, and consider enough factor to establish the model, and my theoretical model of the resolution. And his concept is only in ideal situation. He can only do a simulation in his presentation. And he doesn't consider enough factor to establish the model. And his experiment and setup, he changed the object distance and different curvature radius of the droplets to see the magnification and resolution. And his proof here will be the consider control variable well and explain the experiment process clearly. And here, his cause is lack of parameter and doesn't have accurate experience set up, which just like I mentioned, I think it would not be accurate enough. And the data analysis, we got the angular magnification and the resolution and object distance and the curvature radius and minimum object with wavelength, which about Rayleigh criterion and resolution. And his count is have a comparison between theoretical and experimental and fit with a theoretical value. And his cons there would be the lack of quantitative data, just like I said, it only have a simulation and didn't do enough experiment to prove it, and lack of data analysis. And in my discussion points, I will talk about the Young's equation and the Gaussian optic, which will only use in the scene lens, and Rayleigh criterion and diffraction of resolution to describe the resolution, and the simulation of the shape of water, which about the Young's equation. And in here, my points to be discussed will be the definition of imaging system and optical paths, and the accuracy and consistency of the theory reporter mentioned, and experiments and setup. I will talk about the object distance and curvature radius of the droplet, and the thickness of the droplet, and diameter of the droplet, which will affect the resolution, and different method of the droplet that they use in their presentation to prove the resolution. And here, I will talk about the condition and environment of the experiment process and the relevance parameter in the experiment. And the data analysis, analysis, I will talk about the focal length, which I think it might affect the magnification and resolution. And I will talk about that if the magnification or resolution will affect each other. And the points to be got here will be the result of different parameters and the comparison of different results. And theoretical light doesn't fit with the experiment's value because they only do a simulation and their experiment didn't do enough. So I think I will, in the discussion time, I will talk about this and to find out the problem they have in their experiment. Thank you for your attention.
All right, move on to discussion.
Okay, so I saw in your presentation, I saw you use the Gaussian's law, right?
Yes.
But Gaussian's law only can use in the thickness. Do you know that? Thickness. In the convex lens, you have the thickness and the thickness. Do you know this?
Yes.
And did you make sure your droplet you drop is a thickness or thickness? Did you consider it?
What's the boundary of the thickness and the thickness?
Okay, so okay, look at this. The thickness will look like this, and the thickness will look like this. Because thickness here, you need to consider three parts of it because it might have a diffraction in the thickness. This is one called thickness, and this is called thickness. And thickness, the line that's really it might have diffraction in different ways. So you need to consider it because the thickness will affect the magnification. But you didn't talk about this, so I think you need to consider it. Okay.
Actually, so you think the shape of the droplet will be thickness?
Yes.
Why?
Because since your water volume increased, and you didn't you have ever calculated your curvature radius in your experiment?
Yes.
Yeah, and can you show me? And don't you think that mine would be like a thickness? You don't know, right? Because you didn't do enough experiments and to see. And you see your data. Is it this with your Gaussian's law theoretical line?
Could you repeat your question?
You have a magnification result.
Yes.
And turn to the pad.
This one.
Okay. But I think so you think it's fitted, okay. Then okay. What about you use the lens maker's equation? Can you turn to the page that you use the lens maker equation?
Here.
Okay, so where did you drop the droplet? Where did you drop the droplet?
Just drop the droplets
On
very
what?
close on the slide.
On the slide.
On the slide, yes.
Is you mean like glass or you drop the drop like you see the pixel in your experiment
No.
or what? Because you didn't explain clearly.
For the magnification, I use graph pattern of observing the pixels.
And what did you observe?
The graph pattern.
Okay. Then you drop on the paper.
No,
Drop.
I jump on the slide.
Slides. Okay. And the slides will have a refraction, right?
Why?
Then you drop the droplet directly on your paper?
No, I put for my experience setup. I drop the droplets on the slides here.
Here. And here will there be a refraction here? Because every object will have a refraction, right? Refraction, right?
Maybe a little, but not very obvious.
But why not obvious? Why can you prove it's not obvious? You need to tell me and explain this.
For example, if you let a light go through a glass, you couldn't observe the reflection really obvious.
Why you can't? You can use other ways to find it because you can know the glass, the refraction of the glass, right? And you can calculate it. Because lens makers only can calculate the focal length that without the glass, without the, say, the slides here.
I got your point. Actually, so you mean that the lens maker equation is not proper
Yes.
to be used in this situation?
Yes.
But in the consideration of the lens maker equation, I can just
You can just
for my experiment, I have modified it with this equation.
Okay, so you modify it.
Yes.
Okay, so the next question that I want to ask you is about the things you say about the object distance will affect the magnification.
The experiment parts or the theory parts.
So theory parts and experiment part would be different.
Okay, here.
Okay. So tell me, why the object distance increase, then the magnification will also increase?
Because it will change the position of the object. And
Yes, I know that because you change the object distance. And why? Maybe you can speak about the focal length. Because the focal length of the lens will change. The object
No.
distance. When you have the same water body, right?
if you have the same water volume, the focal length will not be changed.
Yes,
Yes.
yes. And then you change your object distance and why the magnification will be bigger.
Can I use the blackboard?
Sure.
Yes,
Sure, go ahead.
So here, if I supply lens just like this, right?
Yes,
And it's the focal length of this.
yes.
So when the object distance is far from this, okay, it will change the way the light emitting from the object, which will make different magnification.
Yes, so the focal length will affect the magnification.
But the focal length in my experiment is the same.
It's the same.
Yes.
And you change the object distance.
Yes.
Okay, please explain this. Like, you know, why will the object distance affect it? Do you know the main reason of it?
Could you just describe your question more succinctly?
Okay, so here the focal length is same, right?
Yes.
You change the object distance, and now I want to ask you why the object distance change and the magnification will change.
Because it will change the virtual image that it force.
Yes, right.
Yes.
And it's because when you say the object distance increase, and like okay, so you say the object distance increase in the virtual image, right?
Yes.
And when it become imaging,
The object is here, not here.
okay, the object is here in the virtual image, right?
Yes.
When the object distance increase, and maybe you can draw the path of a light and tell me two
Okay.
different objects. Let me draw it here, and draw the lights and to let me
For
see if-
example,
Okay.
in ideal situation, the light emitting from this object
Yes.
will be written like this,
Yes.
right? But the virtual image is actually formed by the eyes, some.
Okay. Then can you draw this?
Then the virtual image will form like this, right?
Yes. And draw this one, this object. And now you can see which one will have a bigger magnification. It's because of the focal length.
This one will have the
Because
bigger
when the-
magnification, right? When the object distance become farther, then you will form a larger virtual image, right?
Yeah. So object distance increase is not, but the magnification will increase. Not suitable. Is not suitable. You need to like say this specifically, like say in a virtual image, because when you do it in a reality imaging, it will change because it is closer to a focal length. The reason is it's closer to a focal length. It's not an image. It's not object distance increase. You need to say it's in this way because it is closer to.
What's the force of my statements?
Okay.
But what's wrong with my statements? Yes, you can explain with the focal length, right?
Yes.
But actually, it just means that the focal length of it will not be changed, but the object more closer to the focal length.
Yes, that's
to
what I think.
focus.
Yes.
Yeah, right.
Okay, so you agree with my point, right?
Yeah.
Okay, so let's keep moving on. So, just like I mentioned, you say, I asked you about aberration, right?
Yes.
I asked you what kind of aberration you have in your experiment.
And respected
Can you
this.
show me your picture of the droplets, the imaging of the droplets?
Which one? Which one? Here.
No, you see it. How do you see the image, the results of the imaging? Like, tell me of it. Because I can
On
see
top
it.
of the
Because
object.
aberration have different.
Yes, but so I use the spherical aberration and the chromatic aberration here.
Okay, so another one that is like, how did you see the resolution? Like you use your eyes or the camera?
No, I converted it to, sorry. I converted it to this equation. The magnification.
Do you do an experiment?
Yes, of course.
And where is your data? Can you show me?
Here.
Here. And can you explain why your error bar is so big?
The error bar here is actually 1 to 2 meters.
Excuse me?
Not
I'm
meters,
sorry?
not 2.
Okay.
Proponent, you will summarize the discussion in 1 minute.
Okay. So in discussion time, I talk about that he said the magnification is about object distance, but I think he should specifically and change the way to say that it's because it's closer to the object distance. And when he talked about the and he also talked about and I asked him, the show question I asked him did the magnification will have a limit, and he didn't answer my question specifically. And I asked him, will the glass affect will have a refraction, and will it affect the ways he used the lens maker equation? But he said he can ignore it, but which I think that object will have a refraction, and it will affect the magnification a lot, so he can just ignore it. And another that I asked him where he dropped the droplet, and he said drop in the slide. So that's a way that he should to modify his equation. And I asked him the signet and the signet definition, and he doesn't tell me that really clearly.
Excuse me, time's up. Questions from reviewer to reporter, opponents for 3 minutes.
Okay, so first I want to ask a few questions to the reporter. So first, do you think that the environment, like the environmental light, will affect your observation? Like for example, like the light on the ceiling, will it affect your observation on the
Which experiments? To which experiments?
like the resolution experiment?
Actually, when I have to do the experiment.
Do you think it will affect?
Yeah, it will affect, because I didn't, so I turned off all the lights.
So you take the picture without any surrounding lights?
No, the light is given by the
So
screen.
only the pen?
Yeah.
Okay. So then I want to ask a few questions to the opponent. Is that so you think that if you have a glass, the refraction will affect the magnification?
Yes.
Then do you think that if you like and do you think adding like, for example, if you add wax to change the shape, would it affect the magnification too?
Yeah, it will.
Okay. Then I want to ask another question is, do you think that the lens maker equation only works for thin and not the thick?
The lens maker's equation have two types. One is the signet, and another is the signet.
So you think he is using the thin or the thick
He's
lens?
using the signet, but
Thick lens?
yes,
You think
the
thick?
one he used is a signet one.
Signet.
But he said his droplet is signet.
Okay, so, and I want to ask a question to both is first to the reporter. So, do you think that the focal length, like you said that it is the object distance is the most important factor that affects the magnification? Why?
Because for my result for the magnification requirements, the object distance will affect it very much.
Okay, then what do you think?
I think it's because of the focal length.
You think focal length affects more?
Yes.
Can you explain?
Because just like you say, he do the object distance. When the object distance increase, the magnification will increase. And the object distance increase in the virtual imaging, it will get closer to the focal length, so the magnification will increase.
Okay, and I want to ask you a question is that how do you define the thin and thick lens?
The signet will have a diffraction in the lens in different way.
So do you think the droplet is thin or thick lens?
in his experiment?
Yes.
In my review, he didn't do the experimental work, so I don't know.
Okay. And second, I want to ask that what do you do you like, for example, on K50, you use the dots, like the dots on the experiment. How do you determine the 50? Like, what do you use? Do you use your eyes to test if it's one dot or two dots? Because you use optical resolution, did you?
Yeah.
Yes. So then you're defining two dots. Then do you use your eyes or another app or imaging system to test if these are the same dot or not?
No, I didn't.
Excuse me, time's up. Review, you got 2 minutes to prepare for your review. You will start your review.
So, as a reviewer, I want to start my presentation on discussing the debate. So first, I think the overview of the reporter. First, they use Young's equations, many equations to discuss on this problem statement. And their experiment method is used across and use the pipette to dip the water on the slide. And the data analysis, they use angular magnification, resolution, counter distance, and curvature radius to support. And on the conclusion, they think that the object distance bigger means magnification is actually larger. And when the curvature is bigger, magnification lower. And with the longer wavelength, then the resolution decreases. And the pros and cons for the reporter. The pros is they have good demonstration for their theory, and they use console or simulations to simulate the ideal condition. And the cons is they didn't do much detail on the relationship between the two factors, and they have a lack of parameters and didn't control the experiment enough. And the pros and the con of the opponent is they clarify the definition of the report and point out some missing points the reporter did not mention. But the cons is that they lack the suggestion on how they could better set up their experiment to lower the error. So now I'm going to talk about the discussion. So the opponent asked that from the equation, is it only used in thin lengths? Then did you consider and why you think it's thin lengths? Well, the reporter answered that the drop is thin length, so we don't need to consider that. But we believe that the length equation they use is for thick length, so we think that in order to, if they need to do some more modification, so it could be used in this scenario. And reflection of the slide will affect the magnification or resolution. And the reporter said it's not obvious, so and they'll also not modify. But I agree with the opponent more, because when there's a difference in the substance, the change in the light ground will be vastly different, which will affect how the frame will be, how we will see the magnification. So we think that if they need more concluding remarks on how this will affect. And next they asked why the object distance increase when the magnification increase, and the reporter answered that the focal length is the same, and the object distance, when they change the object distance, the magnification will differ. And I believe that, well, because I think that the case they're talking on the board, they're setting on the same focal length, and they have discussed that the magnification will change if the object distance will change. So I think that on what they are elaborating on, I think object distance changes in that part, but focal length will also change the magnification too, but they're not talking that on the board. And next, we asked that, will the environmental light influence the observation? The opponent said it will affect, so the reporter said that it will affect, so they turn off all the lights to see the resolution. And we believe that this is correct. And next, we think that if we added like other substance like wax, would it affect? They think that they will no matter is it glass or wax, they will all affect the light ground, which will affect the magnification. And my presentation is over. Thank you.
Thumbs up. All right. Concluding remark from reporter for 2 minutes.
Okay, so I am the reporter from TS Hybrid. Okay, for a concluding remark, for the theory part, for the magnification part, I use lens maker equation and Gauss formula to calculate the width magnification. And for resolution part, I use White criterion and the equation given by this to explain the effect of the deflection, which can help to calculate the resolution. And for the magnification in my experiments, I change the object distance and the curvature radius. And for resolution, I change the wavelength. And I also use console to simulate the trail of light, shape of the droplets, and the spherical aberration. Okay, and for our discussion with the opponent and the reviewer, and for the theory part, we discussed about the object distance and the focal length, and the diffraction of the glass, and we also talk about the Gauss law and the thickness of droplets, which actually will be can be a point to affect the phenomenon very much. But I don't think you will. And for my experiment part, a measurement of the resolution and the magnification, and we also talk about the slides, whether the slide will cause the deflection. And we also talk about the environment of my experiments of resolution and the type of the aberration which might cause the error in my experiment. And we also talk about the shape of the droplets and how the virtual image was formed and the effect of the slides, which may call the reflection, and for me I use the equation to modify it. That's all my presentation. Thanks for your attention.
All right, thank you. Here comes the questions from jury members.
Could you remind me that you use the same amount of the water droplet
Yes.
to control the size and shape of your lens?
Yes.
So have you tried different volume of droplet in your experiment?
Actually, the volume of drop, yes, I tried, and it will affect the curvature radius
Right.
of the center of the droplets.
So you have the data for that?
Yes, but the data only contain the curvature radius of the center. Here.
So what was the curvature? Give me a number.
You mean the curvature in my points?
Yeah, that's right. The one you use.
Here.
I mean the curvature of the droplet.
You mean the center part of my droplet?
You vary the curvature radius, right?
Yes, it means that I change the curvature to.
There you go. So he used different amount of water.
Yes.
Okay? Okay.
Yes.
I got a question for the reporter. You're asking magnification limit. Can
Yes.
you elaborate a bit more? What do you mean by that?
Because I will ask him this question because it will be when the object was on the focal length, it will be the image
Focal
will,
point. All right.
yeah, it will got blurred, right? Image will got blurred.
Why?
So because and you can write a light path, and you can see it can convex into a point, and you can see it. So I think before the focal length, there is the imaging you can saw, but on the focal length, there will not imaging you can see really clearly, and there will have a limit. It's
When you do imaging with optical microscope, you have the object on the focal point,
yes.
or what? Why the object on the focal point would make it blur?
Because the light can convex. Because the light will just like this. You on the focal length and here like this, and here is a focal length, and you can see that it will be like parallel, and you cannot convex, and it cannot
Right.
be convex.
So somehow there's a limit, right?
Yes.
Tell me what determines this limitation. Curvature or whatever index of refraction?
I think it might be affected by the curvature radius. Then, yeah, each curvature radius will affect the focal points.
Yeah.
So it will have different limits.
Any other questions?
I have a comment for the opponent. Okay. So you suggest the reporter, instead of saying how far is from the lens, right?
Yes.
It's better to say, how far is close to a focal point.
Yes.
But actually, the distance between the object and the focal point is, you can have on the right side or left side,
yes,
right?
yeah.
So you should consider that,
Oh
right?
yeah. Yes.
You agree?
I agree with you.
Yeah, I was gonna ask that the object is on the front side or on the curved side. Obviously, it's on the front side, right? Underneath the front.
It will be formed as a flat side.
So what if you reverse it? What would happen?
You
Start
mean
from-
if I
yeah.
change the object to the
To
other
the curved
side?
side, yeah.
Oh, I think, and then I have to modify my equation to.
I think it would be like when you this is a droplet, right? And you put object upon the droplet, and you can put a screen or anything else like paper. And when you put it and look, and light is upon the object. And when the light gets to the object, like maybe you can write a black screen, and the light won't get to the black screen. So it will have like a reality imaging, like shadow on the screen. So this you can also observe this as a magnification, but it's not just like a droplet microscope want to describe.
Correct. Review?
On that
The same question.
The same question. Well, I think that it will change how the because from it like when it comes from different sides, it's not like reversible. Like the light is coming in different routes. So I think that the whole magnification needs to be done again, like with the curved side, because how it moves will be different.
Thank you. Then that's the scoring time.
直接讲。 应该回答讲实项，虚实项的转换。概念。
can show the score for the order. Start from me. 5, 5, 7, 7, and 8. Score for opponent. Start from me. 8, 6, 7, 7, and 8. Score for reviewer. Start from me. 5, 5, 6, 7, and 7. I think pretty much even, right? Okay, let's take a break for 15 minutes.